My name is Brian. I've been a software engineer for 20 years. I've been programming for around 10 years longer than that. So 30 years, more or less. I've developed software on pretty much every platform you can think of. I first used PyCon back in 2004. Actually, that's not entirely correct. I used it around 2001. It was one of the earlier 1.4, 1.5 versions. But 2004 was the first time I was using it at work. I used Python to test telco systems using Corba interfaces. Okay. All right. I'm also a coach for Women Who Code. So yes, there are dudes that work with Women Who Code. I coach the classes for machine learning, data science, and R. Okay. My day job is as managing director for engineering for PES AI. So Jolly is one of my data scientists. PES AI is a New York-based data science and analytics company. We specialize in NLP, information extraction, knowledge discovery, and we have clients here in the Philippines and in the US. Okay. All right. So why are we here? We're talking about data science, data visualization. A key part of any data analysis is being able to share your results. Jolly was talking yesterday about how she was able to share her results using Plotly and Dash. And it's part of our ethos, or part of our principles in PES, that we want to get the data, make the data available as soon as possible, make the analysis available as soon as possible. So we try to get our data out, get our analytics out as soon as possible with the minimum amount of effort required, and basically as quickly and as cheaply as possible. So we use Python and R, but today I'll be talking about R visualization, Python visualization. Sorry. So regardless of what kind of data you're working with, a picture is worth 1,000 words. No? So even if it's a simple data frame or time series in one variable, it's always easier to explain what's happening, to see insights, even with a very basic graph with Matplotlib. And it's really part of the data analytic process to share your visualizations. Even though you can do a lot, the faster you can do your data analytics and your data visualizations, the faster you're able to get feedback from your customers, the faster the business is able to make decisions. And if you're able to give that data and provide the information and the results in a manner that your audience can understand easily, it lets them ask more questions about the data. There are several schools of thought about visualization. Some, if you go to Reddit's Data is Beautiful, it's all about the aesthetics of data. If you attend one of the data visualization storytelling seminars, it's about telling a story. At a very basic level, visualization is really about communication. So it's about getting your message across. So you have to determine what you're trying to visualize, the data, and what kind of information you want to convey as part of your analytics process. You have to know your audience and how they process visual information, which means you have to understand their tolerance for information. So what you might present to as one of your coworkers in the same team that's doing the same research as you would be very different from what you would present to the board of directors, to a senior manager. You have to define the granularity of that your audience is willing to deal with. And you have to know how to use the visuals that convey the information in the best, simplest, and easiest for your audience. On the other side of that, it's important as data scientists or just software engineers that have to make presentations or basic analytics on data, you have to understand what your data consists of, right? So you want to know the size and type of your data, number of columns, number of rows, the type of data that you're actually working with, if it's numeric, ordinal, categorical. And things like the cardinality, which means the uniqueness of the data values. For example, if you're presenting the differences between male and female, the cardinality would be relatively low. If you're looking at different products, for example, for different SKUs for a retail chain, you would have very high levels of cardinality. So these would influence the types of visualizations that you'll be using. Okay. And finally, data preparation. So you can't expect your data to come to you in a manner that's easy for you to visualize. Otherwise, what's the point, right? So a lot of data science and analytics is getting the data from one representation to another. And the tools that we use tend to prefer what's called a tidy data format. So when we talk about tidy data, we try to structure our data to make it easier for our tools, our visualization tools and our analytics tools, to make it easier to analyze and visualize. So very simply put, each variable forms a column, each observation forms a row, and each type of observational unit forms a table. So each experiment, each survey result would be a row, and the entire survey would be a table. So we want to avoid things like joining different tables together. You've done that for SQL databases. You want to normalize to their normal form. For analytics and data science, you typically want just one table, maybe two for lookups. So if you get your data into this format, it's a lot easier to do analytics with the tools that we're providing. Okay. So today we'll be covering primarily Matplotlib and Seaborn. Has anyone used either of these two before? So Matplotlib and Seaborn are probably the most commonly used visualization tools for Python. Matplotlib is actually one of the oldest extant data analytics or visualization toolkits for Python. It's been around that, I think, going back at least 15 years. So in terms of software package lifespans, it's been around very long. It's very stable. It's very well understood, and a lot of people use it. Both Matplotlib and Seaborn are very easy to use and very easy to learn to start using. They have lots of built-in plots, and you just have to realize that Seaborn is built on top of Matplotlib. You can't have one without the other. And even if you just install it and never use it, it will automatically make your Matplotlib charts a little bit prettier by default. So that's usually enough reason to install Seaborn. But the real strength of Seaborn is that it includes additional handy statistical tools, visualization tools for fitting regressions and density functions to your charts automatically. And we'll see that in a bit. So we usually import Matplotlib and Seaborn. So Matplotlib has two interfaces, an object interface and a MATLAB-like interface. That's the PLT that you see there. And Seaborn is usually imported as SMS. First, let's take a look at some of the common visualizations or charts that you might have seen. You've probably done this in Excel on a report, but it's good to go over them and figure out what the strengths and weaknesses of them are. Okay, so line charts. It's a very simple chart that just shows the relationship of one value to another over an x-axis. Usually the x-axis is time. It's most often used to track changes or trends over time. And it's useful to compare multiple items over the same time frame. And you can stack the lines or have them on the same y-axis depending on what you're trying to achieve. So something very simple like this, it's a toy data frame. It's a fake data. I don't really spend too much time over buying coffee, but with one command, with the plot command, you're able to generate a two-line stacked line chart just based on Matplotlib. Actually, you didn't even have to call Matplotlib directly because pandas data frames have a plot method which you can call it just plot your data frame. So the general pattern for both of these packages is you have plot. You choose your chart type, you choose the data that you want to plot, and you choose which goes on the x-axis and which goes on the y-axis. Of course, depending on the chart type, you may only have one variable to plot, and we'll see examples of that in a bit. Questions so far? Everyone knows how to install Matplotlib, right? Phil?
Can you put this kind of graph like Matplotlib? Can you use that into a real-time service, like for example in a dashboard?
Yes. There are tools that will allow you to call Matplotlib in a dashboard. Jolly demonstrated one yesterday. Yeah, so Dash. You can use Plotly, which provides a reactive interface. You can use Matplotlib in desktop applications. So I'm using Matplotlib in a Jupyter notebook, which is probably the most common use case for it. But you can call Matplotlib from a terminal window or from IPython, not IPython, just from IPython or from Python, and it will display in a separate window using a different backend. Okay. So Matplotlib offers a whole bunch of backends. It can output SUV, it can output different raster and vector formats. So you just have to specify which backend you want it to use. So by default, I'm using a PNG output Matplotlib. So if you're using IPython notebook, you just say you give it the cell magic Matplotlib inline to put your charts in line with the rest of your code.
Okay, if I may supply, these backends usually on desktop is Tkinter, Qt. For Jupyter, I think they have their separate backend. So yeah.
So the default, if you're running it in a console without a Jupyter notebook, would be Tkinter. And the nice thing also, if you're using Tkinter, is you can zoom into the chart. If you have a 3D chart, you can rotate it. That works very well. Okay, bar charts. Bar charts are surprisingly useful. So they allow you to compare the quantities or of different categories or groups. So if you caught the machine learning demo downstairs a while ago, we did a little machine learning exercise on the Titanic dataset. This is the same dataset, and I've just plotted here using a single command, using a single function, the number of survivors, whether male or female, and the different steerage classes that they were in. So apparently, if you're a rich female, you have the best chances of surviving the Titanic disaster. Okay. So I'm not going to do any deeper analysis on this. It's just a convenient data set to use when I'm just demonstrating bar charts. Okay. So again, this is a Seaborn plot. So SNS just means Seaborn, and bar plot is plotting method. You'll notice the data is a Titanic data set. The x-axis is the sex, and y is the number of survivors in each class. It also splits it up by categories, by the class, which is another column in the data set. If you only have univariate data, pretty much the only thing you can really plot is a histogram or a distribution. And Matplotlib is a histogram function. What do you call this? Seaborn has the list plot, which very conveniently overlays a distribution curve over your bin data. Okay. So here I just plotted data from the empty cars dataset. And the empty car dataset just tells you what the mileage is for different models of cars, and you can drill down based on the type of car, type of engine, weight, number of cylinders. But I'm just taking a look at the highway mileage for this dataset. So univariate data, basically just want to get a histogram or a distribution plot. So once you get to multiple dimensions, you can do a lot more interesting things. The first plot you really want to do whenever you're plotting bivariate data or X and Y values in the scatter plot. You wouldn't go to any other thing until you've taken a look at the scatter plot first. I'm still looking at the empty cars data set, plotting the mileage for city versus highway as expected. You get a fairly good correlation between the city mileage and highway mileage. So you have to, I plotted it twice because I wanted to show the difference between bivariate plots in, scatter plots in Matplotlib, which is very basic. You get the XY coordinates, it provides the plot points for you. For Seaborn, it's a bit nicer. They call it the joint plot. So the joint plot does the same thing as your scatter plot in Matplotlib, except that it also provides histograms for each variable that you're plotting. So for data that you want to see the correlations, and if they're continuous data, you can use scatter plot or joint plot, depending on what kind of output. So you'll notice that everything here has been very simple so far. We'll get a bit more sophisticated in a bit. Box plots are probably my favorite plot because they display 5 summary statistics in one chart. So you see the lower minimum, lower quartile, the median, basically the IQR range, the maximum, and you can take a look at any outliers as well if you choose to. So this is a Seaborn box plot. This is again the empty cars data set. So I've split it into, well, the chart has split it. I haven't done anything with the data. The chart has split it into the different vehicle classes, and it's automatically determined for each class for the city driving mileage what the interquartile range is. So 50% of the data would fit within this range for that particular class. It shows the whiskers for the interquartile range. For the minimum and maximum, the 25th to 75th percentile. And then finally the outliers, which you see as dots beyond the top whisker, or maybe the bottom whisker. So yeah, box plots are really underutilized, I feel, outside of the academia or research communities. I would love it if more people use box plots. So please use box plots. Violin plots are sort of like box plots. They're a bit nicer to use sometimes because you get an idea of what the distribution is within the range. But it's the same idea. You get a visual of the range for each class. But this time, rather than discrete box, you get a distribution. Again, it's just one line of code from Seaborn. So in statistics, you would use something like a linear model, a regression to determine what the relationship is between the two variables. And Seaborn makes it easy with the linear model plot. So the linear model is automatically calculated. If you wanted to do this in Matplotlib, you'd have to create the linear model and plot the line yourself. So you'd have to do some, you have to import stats models and create the linear model first and determine what the y-intercept would be and plot the line yourself. So Seaborn makes it a lot easier. So if you've worked in R, so this looks very much like ggplot, and I think the ggplot visualization of the charts really influenced Seaborn. So they make it really nice. By the way, I think R is a better data science language than Python. Oh, sorry, this is a tips dataset. So it's a dataset about how much a waitress would earn in tips depending on the time of day or the day of the week. And on other factors like whether the customer was a smoker or not smoker, things like that. So I just wanted to show the difference of the capabilities of the LM plot. So just like in the previous plots where we were able to cut them up based on the classes, for example, for the boxplot. This one allows you to create multiple linear models and show them in a single chart. And again, with a single line of code. The only difference here from the previous plot is the added hue, or hue just means a color. They didn't use color because apparently color might have been already used in Matplotlib. So hue just splits the data into two sets. It builds the linear model separately, but it plots them all together in a single plot. So the tips from the smokers tend to be lower than the tips from non-smokers. So I don't know if your smokers tip your wages as well. Okay, this is something that's actually a lot easier in. One of the things I like about Seaborn is that it's a lot easier to create subplots. So with Matplotlib, you'd have to create each plot separately in the finger. With Seaborn, copied basically from ggplot2, you're able to specify the variable to split the chart up into. So here I've split up the charts based on time of day. So lunch, there are a lot less people eating during lunch, but the regression seems to be fairly similar. For dinner, it's just a separate plot. So you're able to split the data up without doing any slicing and dicing in pandas with your data frames. So the charting libraries can do this for you. It's very convenient. So if you work with pandas data frames, you know, slicing and dicing doesn't always work the way you think. So it's better to, in my mind, if you're doing visualizations or analytics, it's better to let the packages do the analytics for you rather than compute them separately. Okay. Right. Here you can fast it even further based on the day of the week. And I just want to emphasize, I would probably never do this because it's confusing, it's difficult to look at more than probably 2 plots at the same time. It's very easy to go overboard when combining subplots, regressions, conditional variables for your linear models, and trying to fit them all within one plot. It's very tempting to do that because it's so easy with Seaborn and with Matplotlib. But please don't do that because your plots just look terrible after. So yeah.
What do you recommend, sir, if, example, the client wants to see 4 plots in one window?
Yeah.
How will you present it? Example, these 4 plots. How will you present it?
I think in this case it's fine because the data it's very small. If it were 5, I've done plots where I've done plots like 4 by 4, so they're 16. I remove as much detail as possible and just leave a smoothing line.
Impost?
No, I need. It's like spark graphs basically. So a lot less detail. So usually those are just more like it's a cute graph. It's probably not very useful. I can show you later. But if you're working in analytics and the data matters to you, you probably want to have some more information. And you don't want it cluttered by too many regression lines, too much color. So I'm a fan of minimalist plots like this. Of course, if your client wants to give them what they're paying your salary. Right? Okay. So this is as far as I go, I think, with Matplotlib and Seaborn. I'll call them in a little bit the next couple of plots. So I think with Matplotlib and Seaborn and the examples I've shown you so far, you can cover probably 90% of what you would ever want to plot in an academic setting. If you have customers asking for analytics, you don't have to go much further than that. But in the interest of piquing your curiosity into visualization, let's take a look at some other things. A common question, if you're doing this for the first time, is how do you visualize higher dimension data? So you're probably familiar with the IRIS dataset. The IRIS dataset is the hello world of machine learning or analytics. And there are 4 variables, basically. Petal and sepal length and width. Okay, so we're able to visualize 2 variables, xy plots, pair plots. You can draw lines. But how do we show the relationship between 4 variables in a single visualization? It's easy, and we'll just cheat and use pair plots. Pair plots work very well if you have a fairly small number of columns or interactions. So you want to show the relationships and distributions for each pair of columns in your data. So we had sepal length and sepal width. Then we plot sepal length versus petal length and sepal length versus petal width, and you'd end up with essentially 16 different plots. Okay. Of course, you could do that the hard way, but as we've seen so far, it's very easy to get things done with Matplotlib and Seaborn. One command shows everything. So pair plots is, as you might guess, like I just described, it takes each column against the other columns and produces pair plots. On the diagonal, you see the distribution for that particular column. Super convenient, easy to use. And for 4 variables, it's perfect. Beyond 4 or 5, it looks a bit cluttered. The nice thing about pair plots, it's fairly, again, it's easy to add a bit more data. So we're now differentiating by the species. So versus color versus what are the other species of iris bird. We're able to show them in the pair plot, and it's not since we only have 3 different species, it's okay. If there were more than 3, it probably get a bit more confusing, having too many colors in 16 plots. Right? So again, for visualizations, oftentimes less is more. Try to constrain it to probably less than the fingers of one hand, the number of columns that you're trying to project. Okay. Okay, maps. So I don't really work with map data. I don't have a use case for it, but you might be asked at one point in time, okay, can you plot some latitude and longitude points? I'm not using Seaborn or Matplotlib for this. I'm using something called Folio, which is almost as easy as Seaborn and Matplotlib plots. And the nice thing about this is, I'll just below this. There you go. So this is a fully, well, you can scroll around in here. I just put one marker, which is where we are roughly. And you can imagine how easy it would be to add multiple markers, and you can add information about what's at that marker by when you create the marker itself. Right? And this plot, you can see the commented outline. You could save it to an HTML file, publish that on your website, and you have a nice. This is OpenStreetMap data, so you can have an OpenStreetMap based map on your site. The other type of mapping visualization is choropleth, where you shade areas of the map based on different values. Again, I don't do maps so much. I don't have a use case for it, but it's good to know that these things are available. And you can use that. You can get that out of Folio as well. A couple more minutes. Okay. Network graphs might come in handy depending on what you're trying to analyze. So networks with an X lets you build up graphs from nodes and edges. If you're familiar with graph viz, the idea is a network is basically a bunch of nodes connected by edges. So you're just declaring that we have 5, 6, 7 different nodes and 5, 6 different edges. And you can visualize what that would be by calling a draw function. This actually calls matplotlib. The funny thing about this is each time you run it, it generates a slightly different graph because the algorithm that it uses to plot has some randomness built in. Okay, so that's my fish graph. Right. Okay. Okay, we have around 15 minutes left. Yeah. So far we've plotted fairly simple data. We had data coming out of data frames, map information, and network data. These are all fairly well represented in computer science with tables, graphs, and latitude and longitude representations. Where the really interesting things happen are with unstructured data. When you work with text, text is ambiguous. So that's why there are fields of like natural language processing, which always tell you how difficult it is to do natural language processing. So the most simple, probably the simplest way to look at text data is to just cut them up, cut up your text, take each word, and jumble them up into a bag of words. It's what is called the bag of words model. So here, I'm taking a simple nursery rhyme. You know what happened to Jack and Jill? So I've split it up into phrases. So this is a list, Python list. Each phrase is an element in the list. And then I use a count vectorizer from scikit-learn. You don't have to use a count vectorizer. You can just tokenize them individually and count them. But I wanted to show you this. And it'll create a mapping of words to columns. And for each document, it figures out, okay, for this document or this phrase, these words are present in that sentence per phrase. And the common term for it, if you've done computational NLP, is a term document matrix. So the short description is every column is a term or a word. Each row is a document. That's why it's term document. And the value in each intersecting cell denotes the number of times the term is present in the document. So for Jack and Jill on top of the hill, this would be the term document matrix. So you'll note even for this very short passage, we end up with a 20-dimensional representation of the text. So what's the problem there? Well, let's see what we can do with this first. So we have a 20 by 1, 2, 3, 4, 5 rows, and very conveniently we can visualize it as an image. So I'm going back to matplotlib, and I'm using the image show method of pyplot. And it just shows, you give it a 2-dimensional object or a structure, and it tries to map it to an image. So XY coordinates, and it uses the values to indicate a color. Since our data is binary, it's just ones and zeros. For this particular example, I just chose black and white. Okay? So the black squares are the cells where the document contains the term. So I've been hinting at the possible problem with this. What's the problem?
Many spaces.
It's very sparse.
That's what.
So we had the lightning talk about sparsity earlier. And with this short passage, we're already at 20 dimensions. But on average, people the number of words you might use in a given day is probably going to be around anywhere from 2,500 to 5,000, depending on what line of business you're in. Human vocabulary is probably around 15 to 20,000 words. How do we handle that? Well, we could big data it or something. Realistically, that's not what we do. So, an important part of NLP, the computational linguistics, is the pre-processing tasks you might do to make the data more manageable. So, eliminate the stop words, which means the words that don't provide a lot of information. It is articles, maybe some pronouns. You might also normalize the words with stemming or lemmatization. So those are ways to convert words like computation into a more normalized form, like compute, or herself into her. And lemmatization is just two different algorithms to basically the same thing. Typically, stemming is based on just the word. Lemmatization might take into account other features around the word, like its position in the sentence, whether it's capitalized or not, whether it's used as an adjective or as a verb. Part of speech, basically. We can limit the size of our term document matrix to the n most informative words, and we can use something called TF-IDF to assign weight to words based on relative frequency in the document. So the main thing about TF-IDF is the more common a word is, the less likely it is to convey a lot of information. So you use the inverse log of the frequency to assign, for example, if there's a word that's fairly rare, but you see it a lot in a particular document, remember our x-axis, our row, it's probably worth more in that row. So TF-IDF. Okay, so TF-IDF comes in scikit-learn. So scikit-learn is a convenient package for doing machine learning. It comes with different tools for feature extraction, feature selection, transforming data. And TF-IDF comes in the feature extraction.txt package as the TF-IDF vectorizer estimator. Okay. So we train it first. First instantiated the vectorizer. Oh, by the way, I'm using the Yelp dataset. So Yelp is a bunch of reviews. It's labeled with sentiment. I transformed the Yelp document. Yeah, okay. So first I loaded the Yelp dataset. So I don't know if probably you guys probably can't read it, but it says, I love that they put their food in nice plastic or something. That's basically what people wrote when they rated restaurants. Okay. So we're going to apply TF-IDF. I didn't want, there were 1,000 rows in the data set. I didn't want it to have too many features, so we're limiting it to a max features of 1,000. And the fit transform function simultaneously, well not simultaneously, it will train and then transform the estimator and generate the output term document matrix, the transformed term document matrix for our data set. Okay. So there's a warning here. That's probably some version thing. I didn't have time to look into it. But we have a resulting PDM with the dimensions 1,000 by 1,000. Who remembers what PDM means? You know what it means. Okay, so we have 1,000 by 1,000 matrix. And, okay, so we can't see it here, but I just wanted to show you that if you have 1,000 by 1,000 matrix, sometimes you can plot it as an image because the image, I am sure, doesn't really care what data you're plotting. It'll just try to display it the best it can. So you can't really see anything here. If you look at my monitor, it's little dots, and that's because the data is very sparse. The matrix is very sparse. So what would we do to visualize this data? We could make the image bar bigger, maybe. The trick, if you have high dimensionality, is to use dimensionality reduction or decomposition to convert the 300 dimension array, actually at least 1,000 dimensions, convert it to a lower dimensional space. So here we'll convert it to 2 dimensions and see what happens. Okay, so I'm using a truncated SVD. If you're familiar with principal component analysis, this is the thing, except that truncated SVD works slightly better with sparse data, which is of course what our data is. So what decomposition does generally is it finds a way to transform a very high dimensionality piece of data into lower dimensions. So we're coming from 1,000 dimensions. Who can imagine 1,000 dimensions? I mean, 3, I'd have trouble already. We want to decompose that to 2 columns or 2 dimensions, so we can plot it in an X and Y fashion. So here, the same way that we transform, estimators are really nice in scikit-learn because they all work the same way. You do a fit transform and you get your output. And I just did a scatter plot and use the Yelp sentiment of positive or negative as the color marker. And from our 1,000 by 1,000 matrix, we decomposed it to a 2 by 2, 1,000 by 2 matrix, which we can now plot using our usual plotting tools. So this works very well a lot of the time. It didn't work so well for Yelp, probably because the phrases are short. But depending on the data set, if you're using PCA, if you do PCA on the iris data set, it works very well. You're able to see 3 different clusters. But for text, and text is ambiguous, it's hard to work with. So this is pretty much what you can expect when you're trying to do dimensionality reduction on sparse matrices generated out of TF-IDF from text data. If they're easy, everyone will be doing it. All right. So that's pretty much it for me. I wanted to finish on time. So a couple of takeaways from this talk, and I hope you take these away with you when you leave. PyCon offers a lot of tools for data munging, data viz at different levels of ease of use and power. I'm lazy. I try to use the easy ones. But they're plenty powerful enough for most applications. Simple plots on structured data, super easy. Pandas, Matplotlib, Seaborn. You don't even need to use Pandas a lot of the time. Both Matplotlib and Seaborn will take lists, arrays. Representing, I should put the first one. Representing your data in PyD table formats, like I mentioned earlier, makes the analysis and visualization so much easier. And finally, even unstructured data like text can be quantified and visualized if you can find the right representation and apply the appropriate transformations. All right, so that's it for me. I will take any questions if there are any questions.
Hi.
Yes.
I would like to ask more about the psychological part of data visualization.
Okay.
So the colors, the data to ink ratio. So from your experience, so what is the right example size of the axis in relation to the plot, or what is the color scheme? What's the color map, or you're using with different plots? So that.
Yeah, there's a lot of research that's been done on the psychological impact of different colors, what are the ideal ratios for text, the ink ratios. I don't have an answer for that because most of my analytics is internal to the company, and we're able to communicate quite well regardless of even if I have crappy graphs, it's okay. You might want to start with Edgar Tufte's books. You're probably familiar with those. Although I don't think he provides much quantitative suggestions, more of, for visualization, it's like art. So the more of this that you see, you're able to develop a sense of aesthetics, and you can start to tell what's a bad visualization versus a good one. And like foreign food, it's an acquired taste. So the more you try, the more you sample, the more you work on it yourself, the better your plots tend to be. So
you want to encourage the use of box graph.
Boxplots.
Yeah, Boxplots.
Yes.
But
Did you get why?
yeah, I wanted your opinions on like a solid example, so we can use sometimes like we default to the easiest one, like
Yes,
bar,
yes.
line, right?
Right.
But why do you want to encourage? What are your business examples so we can?
Okay. I don't have Wi-Fi. The nice thing about boxplots, well, it's the same thing about histograms. It doesn't just show you the range or what the maximum and minimum are, but it gives you an idea of the distribution of data within a particular class, for example. So if you're looking at height data, for example, you get the mean, the median, the mode for a particular class, a particular measurement. It gives you one measure of, it gives you a couple of statistics. With the box plot, you get an idea of the range and the distribution. So if you're working statistics, you know that normally distributed data, you can characterize it with the mean and the standard deviation, right? It's not always easy to show that level of distributions graphically, unless you're using just like one variable, using the univariate plot, and you have a histogram. The box plot lets you convey a bit more information without having overly complicated things. So the width of the box will give you an idea of how fat or how skinny your distribution is, and the number of and the distance between the whiskers will give you an indication of if there are many outliers, how much data is at the edges of your distribution. Does that make sense?
You're lacking an example.
Yeah. So I wish I could show you the example. Hold on.
Do we need
I
Wi-Fi?
can show you an example, but it's hard. It's not great. Ah, okay. I don't have Wi-Fi.
Do we need Wi-Fi?
Sure, you can connect to the
No, it's okay. I have a lot of stuff. So, okay. So last year I did a quick survey of salaries for software developers, and I wanted to see like things like location, how location influences salary, and this is a truncated box plot. It's missing the whiskers and outliers, but it gives you a lot more information than a simple chart would. So the chart, well, it's a histogram, really, on its side. But if you wanted to drill down deeper, graphs like these give you a bit more information about the range of data for any particular industry, for example. So this is essentially what a box plot would convey. So it gives you the mean and the range of the interquartile range. So you could say that BPOs tend to take less, and the salaries fall within a smaller range. Advertising PR pays above the mean, but there's also a big range of salaries. So it's hard to show that both the mean and the range in a single graph, unless you're using something like this or a box plot. Box plot lets you, what's missing here are the whiskers for the box plot. And I really like the whiskers because it tells you what the outliers are and what the minimum and maximum could be. Okay? So yeah, so this is on my website. Just you can just Google it. But I think that that's a good explanation for why the box plot is superior to just a chart with averages or even or just plots.
Sorry, what's your website?
Baquiran.com. Very easy to find.
Your name?
Brian
And
Baquiran.
Okay, thank you guys, thank you. Check out the Minimalism talk. They're on until 5. So they're all friends there, so please support them on Twitter.